Hello Precalculus students, we are doing lesson 2 in unit 2 today, and we will be transforming the sine and cosine graphs. So let's start by reviewing the basic sine and cosine graphs that we learned last lesson. On the x-axis we have our angle, which we can call theta, and on the y-axis we would have, in this case, the sine of x, or the sine of theta. So this is going to be 0 radians here, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. And then backwards you can go to negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. On the y-axis, somewhere we're going to need a 1. So you could put the 1 right here if you want, or if you want to, you could put the 1 right here, whatever works for you. I'll put the 1 here, and I'll put the negative 1 right here. Okay, so then you just need to use your unit circle. The sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, the sine of 3 pi over 2 is negative 1, and the sine of 2 pi is 0. And last class you learned that these are not connected with straight lines, that they have a specific sinusoidal curve. And that this curve continues on forever. So even though we often just draw one period of this, you can continue it in both the positive or the negative direction. So I can make some more dots and draw some more of the curve over here. The period of the function is the horizontal length before the pattern repeats. So from 0 to 2 pi is a period of 2 pi. It goes 2 pi radians before the pattern repeats. The amplitude is the distance from the midline, and in this graph the midline is right here on the x-axis. So it's the vertical distance between the midline and the maximum, or the distance from the midline to the minimum. It's going to be the same. And that distance is a distance of 1. Let's do the cosine graph. Okay, the cosine graph, you're going to label your axes the same way. This is your angle on the x, and then this would be the cosine of the angle on the y. And you have 0 radians, pi over 2, pi, 3 pi over 2, 2 pi. And then in the negative direction, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And again, you can choose where you're going to put your 1. I'm going to put my 1 right here. And just make sure that negative 1 is the same distance in the other direction. So, now if you look at your unit circle, the cosine of 0 is 1. The cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0, and the cosine of 2 pi is 1. And again, it's going to follow a sinusoidal curve, so it's really the same curve, just in a different position. And sometimes it doesn't look the same until you draw more of the curve. So I can draw more of the curve in this direction, and then it's a little bit easier to see that it's actually the very same curve, just shifted over. Okay, so it still has an amplitude of 1 because the midline is still at y equals 0, and the distance from the midline to the maximum is still 1. The period is still 2 pi because it goes a period of 2 pi before the pattern starts to repeat. Alright, so let's look and see what happens when we transform these functions. Here are all the places where we could put transformations. Now the amplitude, we said, is how far it is from the midline to the maximum value on the graph. And that's going to be indicated by the a value. Sometimes the a value is negative, but your amplitude is always going to be positive. So we're going to say that the amplitude is the absolute value of the a, so that we always get a positive answer. The period is how long it takes before the pattern repeats. And the period depends on the b value, but it's not the same as the b value. The period is going to be the normal period of 2 pi divided by the b value. Let's see, what else do we have? If a is negative, then that's going to reflect your graph vertically. So the graph reflects vertically. Okay, so if c is positive, for example, we would have x minus something, because notice minus is part of the equation. So if the c is positive, it would be x minus a number. The graph is going to move to the right. And in this case, in the example, it would go right 2. And if c is negative, then the graph would move left. And if your c is negative, instead of seeing x minus negative 2, you would see x plus 2. And that would actually move your graph to the left 2. Alright, d, if the d is positive and that's outside of the parentheses, the graph is going to move up. And if the d is negative, then the graph is going to move down. So let's see that in some example problems on the next page. Okay, so the 2 is in the a position. That would be the a sine x. So the 2 is going to change your amplitude. Your amplitude is 2. The b value in front of the x didn't change, so your period does not change. Your period is still 2 pi. If your period is still 2 pi, that's still going to be the length of your graph. So you can still put 2 pi there. You can put pi there, pi over 2, and 3 pi over 2. And if you care to, you can label your negative axes as well. This time, we need to label on the y-axis both 1 and 2, negative 1 and negative 2. Your graph is going to follow the same pattern as the parent graph for sine, which is midline, up, midline, down, midline. The only thing that changed is our amplitude, which is 2. So instead of going up 1, we went up 2. You still need to draw a nice sine curve. Do not connect with straight lines. And then you can continue on the left to show another period as well. Okay, in this graph, 2 things are going on. First of all, notice it's a cosine. Cosine has a different shape. It has the up, midline, down, midline, up shape. And we're changing the b value this time. So our amplitude doesn't change. Amplitude changes when there's a number in front of cosine. So your amplitude is 1, the same as the parent graph. Your period is 2 pi divided by the b value. So it's 2 pi divided by 4, which simplifies to pi over 2. So that means that it takes a whole length of pi over 2 before this graph repeats. So I'm going to put my pi over 2 here so that I can still show my graph in this area. Half of pi over 2 would be pi over 4, and half of pi over 4 would be pi over 8. So here I need to figure out what's going to go right here. Looks like I'm going up pi over 8 each time, so to find that one I would do pi over 4 plus pi over 8, with a common denominator would be 2 pi over 8 plus pi over 8, which is 3 pi over 8. So this is 3 pi over 8. My amplitude did not change, so my amplitude is still 1, and this is going to be negative 1 here. So cosine, remember, starts up, midline, down, midline, up. Up, midline, down, midline, up. And draw a nice curve. And you can continue that. Now if I'm going too fast for you, you can pause the video, you can rewind it and hear it again. The next one is going to combine a few ideas, so if you'd like to pause the video here and try problem 5 before I show you, feel free to do that. Okay, in problem 5, the negative is going to reflect your graph. Reflect. And the 1/2 will change the period, so that will be 2 pi divided by 1/2, which is 2 pi times 2 over 1, which is 4 pi. And the 2 will change your amplitude to 2. We're doing a sine graph, and sine is midline up, midline down, midline. But it's flipped, so it's going to look upside down. It's going to go midline down, midline up, midline. Let's label your axes. Now my period's 4 pi, so I want 4 pi here. Half of 4 pi is 2 pi. Half of 2 pi is 1 pi. And I can reason 1 pi, 2 pi, this must be 3 pi. And this will be 0. On my y-axis, I need an amplitude of 2, so I need 1 and 2, -1 and -2. Okay, so sine starts on the midline. Normally I would go up, but because of the negative, I'm going to reflect and go down. Back to the midline, up, and midline. So in this graph, we reflected upside down, we stretched it vertically so it had an amplitude of 2, and the 1/2 changed your period to 4 pi. Okay, when you are done with this page, you can turn to the next page. Okay, it can be tricky when we change both the period and we have a phase shift. So this minus pi over 2, you know, is going to shift to the right pi over 2. And this can be called both a horizontal shift or it can be called a phase shift. The 2 here, you remember, changes the period. So the period is going to be 2 pi divided by the b value, so 2 pi divided by 2, so the period is pi. So I can put pi over here. Half of pi is pi over 2, and half of pi over 2 is pi over 4. So if we're counting by 1/4 pi, I have 1/4 pi, 2/4 pi, 3/4 pi here. And my amplitude is still going to be 1, and I'll need a -1. So if I shift to the right pi over 2 before I start my sine graph, and remember sine is going to be midline up, midline down, midline. My graph starts right here. So I have midline up, midline, and then I've run out of room. So I need to go backwards. So here's part of my graph. The rest of it I know is going to continue over here, but I really am out of graph here. So I'm going to go the other direction, and I'm going to just use a new color to show that I started right here, but now I'm just trying to finish up at least a full period, if not more. So if I want to finish a full period, it's going to go here, and I could continue going backwards as well. Okay. Alright, so my sine graph actually started right here. Alright, and let's try another one. In this graph, we've got a lot going on. So you may need to draw a box. We'll see if this is going to come to us or not. We have something new here. We have a vertical shift. Vertical shift, which moves our graph down 1. Vertical shift. Now I believe we did vertical shift last lesson, and I like to do that by just moving the midline to start. We have an amplitude of 3, comes from the 3. We did not change our period because there's no number in front of the x, so our period is still 2 pi. And this plus pi over 4 shifted us to the left, pi over 4. Now since we didn't change our period, I'm going to put 2 pi right here. This is going to be pi. This one's going to be pi over 2 and 3 pi over 2. And I need 1, 2, 3, -1, -2, -3, and actually I need to go down to -4, and here's why. My midline shifted down to -1. So here's my midline right here. That is now the middle of my cosine graph. Okay. So normally I would start right here. Nope, for the cosine I would start 3 above for right here. But I'm moving left pi over 4. Now if I move a whole box, that's pi over 2. I just want to move left pi over 4. So that puts me in the middle of the box. So let me review my starting point. -1 told me this is my new midline. Cosine usually starts above the midline, hits the midline, below, midline, and above. So cosine usually starts high. So normally from the midline I would count up 1, 2, 3, and I would be right here. But I also shifted left pi over 2, so I start here. Alright, my next point would have been here at pi over 2 and on the midline, but it also moves left. My next point would have been at pi, and it would have been 3 below the midline, but it also moves left. So you can see all of my points are going to be between the lines. The next one goes back up to the midline, and then I go up 1, 2, 3 from the midline. So it looks like a V shape. Cosines always look like a V shape when you just have the dots, but you need to make the curve. So you make like a rainbow here, you make a rainbow here, and then this is like a U shape in here. So that's one period of the graph, and you could continue to draw another period over here if you chose to. Alright, this is the one where I think we've got a lot going on, and we might need to try a new strategy, which is to draw the box. Let's see what we have going on first. 3/2 is the amplitude. Now remember, 3/2 is the same as 1.5, so if that helps you figure out where your amplitude goes, then you can write it either way. The period is 2 pi divided by the b value, and the b value here is 1/2. So 2 pi over 1/2, which becomes 2 pi times 2 over 1, which is 4 pi. The minus pi moves you to the right pi, and the plus 1 moves you up 1. So I'm going to take the period 4 pi, and I'm going to put 4 pi right here, which makes this 2 pi, 1 pi, and 3 pi. And I'm going to label 1, 2, -1, -2. And since my midline's going at 1, I'm going to need more on the positive. I'm going to draw my midline at 1. Okay, and here is where the box could be helpful. So the box tells you where to start and stop. So here's my purple. I'm moving to the right pi, so that means I'm going to start one box to the right, because that's pi. And that means I'm going to also end one box to the right, so I can kind of create that here. That's going to be my 5 pi. So my period of my graph will happen between pi and 5 pi. I can also box in the top and the bottom. So my amplitude is 1.5. So if I go up 1.5, then I can create the top of my graph. And if I go down 1.5 from the midline, then I can create the bottom of my graph. So my graph happens in this purple box right here. A sine graph starts on the midline. So I start on the midline, then it goes up, goes back to the midline, then it goes down, oops, down here to the purple line, and then it goes back to the midline. So midline, up, midline, down, and midline. And you could continue that in the other direction as well to draw more periods of this graph, because it goes forever to the right, it goes forever to the left. Okay, if you need to pause that and rehear it, please feel free to do that before you go on to the next page. Okay, in problem 9, we have something new that we haven't seen before. What we've seen before is y equals a sine, and the b is factored out, and then x minus c plus d. Our b value is not factored out, so we have to factor out a common factor of 2. The way you do that is you divide this by 2, you divide this by 2, and that factors the 2 out. So our new equation is y equals negative sine, factor out that 2, we're left with x minus pi over 4 plus 1. If you're not sure if you did it right, distribute that 2 back to see if you got the original. 2 times x is 2x, 2 times pi over 4 is pi over 2, so I know I did it right. Alright, so now, my amplitude did not change even though there's a flip. So my amplitude is 1, my period is 2 pi over 2, which is pi. I do know that there is a flip or a reflection. I'm going to go right pi over 4, and I'm going to go up 1. So this seems like another candidate for a box. Let's label our axes. My period's pi, so this will be pi. This will be pi over 2, pi over 4, 3 pi over 4, and I need a 1 and a negative 1. Okay, I'm going to do my midline. My midline went up to 1. Alright, so I keep forgetting that that means I'm going to need to have a 2 up here so that I can go above my midline. So my midline is at 1, and I'm moving pi over 4 to the right. So here's pi over 4 to the right, which means that my endpoint will also go pi over 4 to the right, which puts me over here. Pi plus pi over 4 is 5 pi over 4. Alright, my maximum is going to be 1 above the midline, and my minimum will be 1 below the midline. Alright, the sine graph will normally go midline up, midline down, midline, but this graph is flipped, so it's going to start right here, because I shifted to the right, pi over 4, and it's going to go midline down, midline, up, midline, like that. And you can draw more of the graph if you so choose. Alright, we are going to now graph the equation of this Ferris wheel, the position y of the Ferris wheel cart relative to the center of the Ferris wheel over t seconds. So we're going to put t seconds over here, and we're going to put the position y over here. Now this looks messy, but it actually works out pretty well. We know that we have a negative here, so the negative is going to reflect the graph, so it's going to be one of these graphs. The 20 is the amplitude, so amplitude equals 20. The period depends on the v value, so the period is 2 pi divided by pi over 15, which is 2 pi times 15 over pi. Your pi's cancel, so your period is actually 30. No pi in your period. T plus 10 moves the graph left, 10. Alright, so here's 30. That's my whole period. That puts this one at 15, 7.5, and 22.5. We did not shift up or down, so my midline is still going to be on the x-axis or on the t-axis, but we did shift to the left 10. So this is negative 7.5, and this is negative 15. So when we shift to the left 10, it's going to be somewhere around here, closer to the negative 7.5 than the negative 15. So this is shifting left 10, and that means since we're going back about a box in a third, we're going to go back about a box in a third here, and we're going to finish somewhere around here. Okay. My amplitude is 20, so I need to put 10 and 20 on the y-axis, negative 10 and negative 20 over here, and that can form part of my box as well, so that the highest it goes is 20 and the lowest it goes is negative 20. Alright, so here goes my Ferris wheel. My Ferris wheel is a cosine graph which normally starts high, but it's negative, so it's going to start low. And I started before this negative 7.5 line, so my next point is before the 0. My next point is before the positive 7.5 line, before the 15, and before the 22.5, which is actually right here. And then you want to draw in the curve. So this is the height of the Ferris wheel as the time is passing. Alright, and one more. This one's about the temperature of a city, and it's going to work out pretty much the same. It's another negative cosine, so it's going to be reflected. Reflected. Okay, it was hard to write that. But this is your shape generally. 25 is going to be the amplitude. Your period is 2 pi divided by pi over 6, which becomes 2 pi times 6 over pi, which becomes 12. So your period is 12. Your graph shifts to the right 1, and your midline is going to be at 65, so that's up 65. So I'm going to start by graphing my midline up 65, and I'm going to start to the right 1, and my amplitude is 25, so 65 plus 25 gives me 90 as my highest point, and 65 plus minus 25 is 40 as my lowest point. Now this graph is already made for me, so I need to figure out how much am I going each time. My whole period is 12, and every graph is cut into 1, 2, 3, 4 pieces. So each piece of the graph will be 12 divided by 4, so it will be 3 months. So if I start my cosine graph low here, I'm going to go 3 months, 1, 2, 3, before I hit the midline. 1, 2, 3 months before I hit the top. 1, 2, 3 months before I hit the midline again. 1, 2, 3 months before I hit the bottom. And then you want to graph the temperature of this city. Alright, and then you are done with your notes. Study over them so you are ready for class tomorrow.